Ladies and gentlemen, please welcome AIAA Science and Technology SciTech 2015 Forum General Chair and Professor and Head of Aerospace Engineering at the Pennsylvania State University, George Lesueur.
Good morning, everyone. You did better for Jim yesterday. I'd like to start this morning by thanking each of you for participating in SciTech 2015. Over 3,300 of us chose to be here with our fellow professionals, sharing ideas, expanding our knowledge, making new friends and meeting old partners, and furthering the spirit of exploration that pushes us forward. Your energy, interest, and enthusiasm have made the past 2 days fly by very quickly. The buzz in the exposition hall at the reception last night is evidence that we are renewing and making new connections that are truly important to the future of our industry. Of course, when you have the right blend of people from academia, government, and industry in the room, insightful and productive conversations naturally follow. As we reach the midpoint of SciTech, we might reflect on some of our forum themes. The importance of government policy and investment as it affects the work we do in aerospace R&D, the tremendous opportunities that arise from being part of a global aerospace enterprise, how the technologies we develop also change the way we work in design, manufacturing, innovation, information, and operations, and our responsibility to assure the development of future talent in our industry. I'd like to congratulate and thank Professor Dame Ann Dowling once again for honoring us yesterday evening with her Dryden Lecture. And congratulations again to all those who received awards at yesterday's recognition luncheon. Their accomplishments and discoveries inspire and motivate us all. Please remember that there will be a second recognition luncheon tomorrow at 12:30, which will include the presentation of the $100,000 Walter J. and Angeline H. Critchlow Trust Prize to the recipient, Professor Satya N. Atluri of UC Irvine. I'd like to take this opportunity to thank once again all the volunteer members of AIAA who served on the Executive Steering Committee, the Forum Organizing Committee, and the Technical Program Committee. Will all of you who are here this morning please stand and be recognized one more time for your tremendous contributions to SciTech. I'd also like to recognize our sponsors whose support helped make this forum possible. Our premier sponsor, as you know, is Lockheed Martin, and our additional sponsors include Airbus, Bastion Technologies, Boeing, Crane & Associates, D-Space, Dunmore Corporation, and Smart UQ, as well as our media sponsor, Aerospace America. I hope all of you will be able to join us at 12:30 today for our luncheon in the exhibition hall. Visiting the exhibitors is a great way to see the latest and greatest in the aerospace marketplace. And please don't forget our Twitter contest, for those of you who are participating. Use the hashtag AIAA SciTech with your tweets, and at the end of the week, the individuals with the most tweets will win some nice prizes. Even though I can't win the contest, I'll be tweeting now and again, and look forward to interacting with all of you. Now, to the meat of the morning. The topic of our plenary session this morning is the future of design, a discussion of the trends that will influence the aerospace concepts we may be designing just beyond the next decade, the changes coming, planned or not, that will influence our design processes and tools, and finally, a look at aerospace design education. As we get to the Q&A portion of this plenary session, please use one of the mics that I think are in the two outer aisles. Many of these sessions are being live streamed, so we want our remote viewers to be able to hear the conversations your questions inspire. If you'd rather not use a mic, please get the attention of one of the AIAA staff members, and someone will bring you a question card. To get the discussion started, please welcome the panel's moderator, Rich Christensen, VP of Sierra Lobo. Rich? After they come.
Thanks, Rich. Okay, we're going to start getting formal right away and have a seat. Welcome, everyone, and I hope you choose to participate in this discussion. That's sort of the format we're going to do. And before we go any further, let me get up the first charts. Oh, yeah, okay, that worked. Isn't this cool? So, you may have noticed on the printed program that we had Dr. Bob Lebec as one of the panel members. Unfortunately, he has a circumstance that has prevented him from flying out here and probably terrorizing most of you. We now have the kinder, gentler version of Bob from Boeing, and that's Rob Gregg. Rob did an outstanding job at aviation in a very interesting discussion on the future of CFD. And so I think his background and experience will add to the meat of this conversation in a way that Bob could have done, but maybe, again, in a more sane way.
I'll try.
Next, at the far end, is Mark Mommer of Penn State. Mark last year was the recipient of the Piper General Aviation Award for his outstanding contributions in design and technologies to that community. And finally, we have Juan Alonso from Stanford's Aerospace Design Laboratory. I got to know Juan while he did a stint at NASA headquarters running the Fundamental Aero program, and sort of that my connection with most of these folks and the work they've done is for myself. I spent 15 years in my mid-career at NASA running the NASA's aeronautics programs and at the tail end there, including the reusable launch vehicles development activities. And so I have a passion about the subject of design concepts, and the processes we use to prove them. So that's the audience, well, that's the panel here, and let me try to get to the next chart. That still works, pretty cool. I'm easily amazed by technology, So the scope of our discussion is going to break down the subject of what's in our future for design in three topic areas. We're going to first talk about design concepts, then move on to design processes, and then design education, and we hope to get through this in the next 45 minutes. But first, let me get a little audience participation here. How many of you, raise your hand, flew here to the conference? Okay, amazing. So everybody arrived in a 200-year-old design concept, wing, body, tail. How many of you believe that the airplane you flew in used a room of 120 female computers and designed by a bank of 200 engineer smokers? Okay. Okay, so the vehicle has been designed, at least within the, using tools and processes within the last 70 years. How many have an advanced degree in aerospace engineering in the last 20 years? Okay. You've been taught the same way the rest of us have before that, so not much has changed in that, and I think we'll have some interesting discussions on that. So let me start our conversation, and I really hope that whether it's through your tweets or filling out cards or stepping up to the microphone, can also begin to participate in this discussion, because what I hope to do is from here until next SciTech is to begin to define what the things are that you think we should be bringing to you on this subject. What is it you want to learn about and hear about from experts, or maybe participate yourself in workshops on this very subject and do the things that Rob here did on the subject of CFD. So please be thinking about that as we go along. The progress in research and technology development in aeronautics and space and all that, I think, are really led by design concepts and technologies. The tools that we use are capture the very essence of what we know about aerospace concepts and designs. And so let's start with the dialogue with design concepts. Okay, that doesn't work anymore. So we'll just leave this chart up as sort of the framework, and I'm fooling you anyway. All I have on this is a yellow sticky. So we have our conversation is going to be pretty much vehicle-centric with regard to aerospace design, and in all likelihood, because of our background right now, we'll talk about airplanes in that sense. If we talk about the changes that have either been tried in the past or looked at, I mean, is there any innovation, or are we just plain crazy to think about we're going to be seeing things in the future that are more than wing, body, tail? So let's begin by having some input from each of you on kind of thoughts and debate on where actual design concepts are coming from and how they're being driven perhaps by new technologies. Rob?
Well, airplane design is a set of, it really is a balance of a number of requirements, and those requirements do evolve, but they're also influenced by the technologies that are applied to the concept. And so as we go to the future, I think we're going to be seeing, as things such as higher bypass ratio engines, I think it's going to drive a need to be a more highly integrated configuration. Exactly what that means in terms of whether it's a wing body or a blended wing body or some other configuration, I think is still to be determined. But as you go to these higher bypass ratio engines, how do you integrate that configuration? And how do you, you're going to have a smaller core, so how do you power or get all the power requirements in order to control the airplane? And so those are all the kind of the new balance that you're going to have to get to as you proceed to the new technologies of the future. And it may not be limited only by the engine. So I don't know, Juan or Mark, if you have other ideas about some of the technologies that could be applied. I also happen to believe that aerodynamics is not done. We have a lot more further improvements we can make to the configuration, even in today's type of configuration.
I certainly think those comments are valid for commercial transport, which is probably we'll see wing and tube for a long time. It's certainly my experience that the prediction is a lot easier to do in retrospect. And about half of my predictions are wrong. So, but I think the exciting thing is the tools allow us now to make configurations that are well suited for the mission, as opposed to just picking the configuration you think is best. So we're starting to see all kinds of unusual things happening, quadcopters and so forth. I think UAVs are going to open the door for all kinds of novel configurations. Electric power allows the possibility of distributed propulsion, which is completely new and different than what we've done in the past. And I hope sailplanes look pretty much the same as the one I own now. Otherwise, it'll be expensive.
Well, I tend to agree. I'm wary of trying to describe what the airplane of the future might be, but what I'm certain of is that there's not a single silver bullet in one particular technology that is going to bring the next set of configurations to the level of performance, environmental performance, reliability, so on and so forth that we require. So I think of design as the art of compromise, whether it's a transport or something else. And I do think that the opportunities to do new configurations are going to rely heavily on how we understand the interactions between the competing requirements in the various disciplines of the design. So So I see designs evolving in a way in which the various different disciplines are much more closely integrated than what we've seen so far. And we'll talk later about the tools, but the processes and tools are going to have to reflect that kind of situations.
I will point out that, if I remember the numbers right, since the 707, today's airplanes are 50% better aerodynamically and 50% better on the engine SFC. And so they're, even though they may look similar to what they looked like at the beginning of the jet age, the performance differences are substantial. And so is there another improvement of the same kind of level is the question for the future, right?
So I'll just say, when I first started, I mean, the dream of laminar flow was almost here, whether you're talking about subsonic or supersonic. I mean, in a way, when I started, that was going to be one of the breakthroughs that was going to allow us to do all sorts of things with higher aspect ratio and, greater economy and things like that. I mean, there does not seem to be a tipping point in any one of the disciplines, whether it's multifunction structures or maybe autonomy, which may or may not influence the design. So, any other strong opinions on where we are in technology?
Bob Liebeck's not here, but I can quote him: laminar flow is the future and always will be. I hope he's now wrong. I think laminar flow gets re-examined about every 10 or 15 years. It's either this iteration or the next one. It will be there.
Yeah.
But that's a prediction. You can mark it as wrong in 10 years.
There are elements of laminar flow that are already beginning to be in the airplane design today. So certainly on the Boeing products, I can't speak to all the Airbus products, but we're incorporating natural laminar flow in the inlets. We're incorporating natural laminar flow on the winglets for the 737 MAX. So it's beginning to happen. We actually have an HLFC tail on the 787-9. So it's showing up. Is it, we can use it much more than we currently are, but it's a start. I think it's just a way of beginning to inch its way into the basic design.
Yeah. I do think laminar flow is making a slight comeback. I think in limited extents it'll begin in the next near future. I mean, you guys have announced some products, like you said, but I think further use is likely to happen in the future.
That's right.
Yet, when we restrict ourselves to a tube and wing configuration, we know the limited extent that that laminar flow can be used in order to lead to improvement. So I like to also think of much lighter structures, higher degrees of flexibility, as you mentioned, improvements in engines that are likely to be almost 40% of the improvements that you're actually seeing, and the innovative ways in which you may integrate those engines in the new configurations. I also see less sexy things that may have a tremendous impact, like more electric airplanes, but not necessarily in a main propulsion plant, but rather in many of the systems that are used within the airplanes. And I think all of these things are going to impact how we design those vehicles in the future.
So in reality, there's really no single disciplinary breakthrough that's going to revolutionize design concepts. We really are on a frontier of multidiscipline approach, making sure that everything comes into balance, and things like multidiscipline optimization is going to be kind of the rule that guides
It's going to be a requirement.
how much of any one technology really gets introduced.
Right.
There's no doubt the toy box has gotten filled with a lot more toys.
Yeah. So let me talk about another angle here. I look back on some phases of my career involved with design, and certainly in the old days, it was about design for performance. How do we go faster, further, higher? The good golden days, as they're referred to. But then in the late 80s, early 90s, this idea of cost as an independent variable, and all design decisions need to be driven by cost goals, cost targets, and all that. Then in the late 90s, at least from NASA, we were very involved in building up an aviation safety program, and design for safety was sort of a theme that we kind of put out. Can we fundamentally change the way aircraft or vehicle systems were designed with the ultimate goal of ultimate safety? And that didn't work out all that well. There's been other fads that have come through, And today there's, at least for the past decade, we've focused on green design. You know, but cost is still there. Now we want to be more green. Yes, we want to be more safe. In the future, we're going to be hearing more about how cybersecurity may influence future operations, and does that become a critical element in the design decision process?
Well, and you also brought up autonomy could have an impact, right?
Autonomy.
You're likely to have more autonomous or more automated flight deck. And so how does that impact the aircraft design is going to be an interesting question. And the perception from what does that mean to the flying public? You say it's fads. I think we go through times when we have emphasis on certain things, when there's a need to have an emphasis on those. I don't think they ever disappear. I think they're part of the basic design at all times. And so safety is always an area that needs improvement. I think fuel burn or emissions, are very highly related, and we're always going to be going after reducing both the emissions and the fuel burn. And noise is a part of that.
And these things become commonplace, and they're just integrated into the process and are no longer special.
That's right.
They're just there.
Yeah. Just another of the design considerations.
What do you guys think about introducing manufacturing constraints more in the design process? Is that something that is likely to have a tremendous impact?
It already is. Manufacturing is a really important thing. So while we've had some of these, looks at these advanced concepts that are look very cool, how do you manufacture them becomes a question. And so that has to be a part of the basic design early on. And it's not just the manufacturing piece of it, it's the maintenance as well. The airlines want an airplane that's not only reasonable to purchase, but also low cost to operate.
And easy to repair.
Easy to repair is a part of that.
And I like to tease the industry people that we adapt in the universities more quickly than they do, because I get a new engineering staff, completely new, every 4 years. So the inertia is not there. And we do emphasize that from the beginning now.
So I'll quickly touch on one element that only comes up every once in a while, and that's limitations on strategic resources, like the disappearance of fossil fuels, and that's driven a new wave of invention and innovation, and perhaps influence on future designs. On should we be looking at alternative fuels and things like that? So again, and whether they're fads or phases, as I looked at them, what generally happens is we learn how to design for cost, and we learn how to design for safety, and all those end up getting encoded in our processes and tools and techniques. And as you say, move on. We never lose that.
Right. But it does offer some interesting, in cases such as electric power, where you had the Breguet range equation. How do you do that with electric power airplanes? You have to be able to go back and look at those kind of basic equations that we use and say, how am I going to use this new technology? And so it's important to be able to look back and say, how are we going to address, or how are we going to look at these airplanes when we really haven't had to in the past?
Yes. In fact, you may use some battery chemistries for some electric small airplanes that gain mass as the flight proceeds. So all those things can be looked at. But the physics are beginning to be better understood. So the incorporation of such constraints into the design process, I think, could be fairly straightforward. Yeah.
Okay, let's move on. I think to cap part of this discussion.
Could I say one thing?
Sure.
So we focused the discussion a little bit on commercial transports, but as we speak about the future of design, I think there are tremendous opportunities in many other areas.
Yes.
We've all touched upon a little bit, but I think the UAV revolution is something that needs to be looked at quite carefully. People are interested in doing personal air vehicles, and those may bring about some very different design challenges. I think the configurations that we might see in the future may require that we rethink some of the ways in which we do design. So I like to put out a word out there for the young people in the audience that these are challenges that are coming and things that somebody's going to have to come up with solutions for.
And the design space opens up on how to solve some of the future
It's
things.
exciting time.
substantially.
It's huge.
Yeah.
It is
So
exciting.
took the words right out of my mouth. I don't need to go on that, but I will say, because that is the opening. I'm currently the chair of the Unmanned Systems Program Committee, AIAA, and I think that's a whole new frontier, not only from technologies, but applications and the types of things we design. So, okay, moving on to talk about design processes. So 100 years ago, the Wright brothers sort of invented the scientific approach to really beginning to understand parametrically how things work to make things fly. In the heyday of aeronautics, when we were doing X-planes and things like that, and beginning to really develop a lot of the aviation industry, we would have bays of engineers and led by, integrated within a multi-function hybrid matrix organization that did enormous amounts of drawings and design and test and things. And then there was another idea with Kelly's Skunk Works, where small, elite project teams that could rapidly move from idea to prototype. Things that have happened in the past couple decades with Boeing moving into more of a global design team, 24/7 processes. So now we've gone back to a much larger scale and a more complex system with many moving parts in the design process. And now even today, whether you would agree with me that we're on the verge or frontier of other approaches, we have a lot of competitions going on when using crowdsourcing techniques. We have challenges to bring additive manufacturing, 3D printing earlier into the process of understanding what our design options and design decisions are. Things like the Airbus Fly Your Ideas. There's the Design Build Fly program that AIAA puts together. The fun one that I found was General Electric's Santa Sleigh design activity, where people compete and build with 3D printing new ideas. So where do you think we're heading with these kind of trends of massively parallel people, inclusion, involvement, great diversity of ideas that somehow self-filter to the best answers given specific questions that are put out for new designs? I mean, is that the wave that we ought to be riding?
It's a hard question. Again, it's the future. I think in former times, you started out with a weight estimate and you did some aerodynamics and then you did some structures and you kept going around basically that loop till you finer detail. And now we're adding in many other things. I think the design process probably depends as much on the mission as the configuration does. What's the best process for a particular aircraft mission? And I think we'll have the big former approach, and we will have very small, light on their feet teams. We'll have the skunk work approach, depending on what you're trying to do. So I think we're building up what we've had. We're not, and it will also open up the opportunity for new things. I think there's a danger in that there's an interest to automate this process, and that's pretty exciting. And the tools now are amazing that you can turn a student loose. They push some buttons and out comes the design. But as was pointed out, some of the physics and the equations are changing, and you need that fundamental understanding to say, no, this tool is not good for that particular mission, and be light enough and experienced enough to know when to back out and go to fundamentals.
For me, the processes of the future, whether it's crowdsourcing or it's going to be a sort of tiger team of experts in various different areas, many of these things may be instantiated for appropriate design tasks, but there's some essence to what the design challenges are going to be. Design will remain essentially a process of discovery. of learning about the design as you proceed along with the design. This iterative nature of the design is not likely to go away because we have more computational capability. So I think the organizational structures for design are going to have to incorporate that process of discovery, that iterative nature, those basic physical models that now we may be able to evaluate much more quickly than we were doing before. Crowdsourcing, I have yet to see how that would map directly to vehicle design, but I do have a thought on how I've seen recent small companies do very well with design by putting together smaller teams with a lot of young people who have extreme interest, energy, capability,
passion,
knowledge about the tool, and passion, together with a handful of more experienced, older folks that can allow the team to evolve in this iterative process without going into the typical pitfalls of the simple mistakes that one makes when you're learning how to do design. So I do see these types of organizational structures being much more prevalent in the future. And I don't know how disruptive this may be to large companies like Boeing, but maybe Rob wants to comment on that. So.
Well,
And whether you're mimicking something like this within your own organization or not.
yeah, as we're talking through this, I think what tends to happen is early on, you have all sorts of different ideas about what the airplane or the vehicle could be. And having a small team that gets all these ideas, and maybe it gets ideas from multiple sources, but being able to look at them in a fairly consistent basis and a very wide-reaching, having that more global system approach, I think is very useful. But as Mark pointed out, you need to have enough, and you pointed out, you need to have some of the experience to say, is this going in the right direction, or is there something you just haven't identified? But then after the initial concept is kind of, coming together, it then becomes a much more, you have to go through the process of designing all the parts of the vehicle and making sure you have something, at least from a commercial standpoint, being able to certify that. And so there's different stages of the design that I think early on a small team makes a lot of sense. And as you proceed towards finally flying the airplane, the size of that team varies.
Excellent. So I've always been a fan of build a little, fly a little, build a little, fly a little, very iterative approach to to locking in design decisions as you go along. I think it is probably more cost effective than the really huge drawn out approach that we may do. But that's the main thing in there, and it's certainly going to become more critical in whether or not we adopt any of these new techniques or not. With the security conscious world that we're moving more into, the trust in how those design decisions were made, and do we really want to put the significant money in investing in those for public consumption is going to be a very serious consideration, and that's another aspect that we're beginning to really address within AIAA is this whole cybersecurity aspect, and we're all being asked to look at it. How does it affect, for example of this discussion, design? And I think that's something we'll tend to explore over the next year.
Right.
Okay.
I will add one other thing, and that is I think that there's still plenty of opportunity for more automated processes that we use today. Now, having said that, you need to have the ability to look at those results and make sure, it's not just a black box that's occurring. You need to have engineers involved in that to make the decisions to make sure that things are going in the right direction. But I think there's plenty of opportunity for further automation and integration.
Yeah, that's all right. Let me throw something out there and see your reaction if we have time, Rich. The analysis capability in whatever discipline, you and I like aerodynamics, but there's many other areas where the simulation capability has improved tremendously. In fact, you'd argue over the last 20 years, our analysis capability is growing almost at an exponential pace.
Yes.
The key thing that I see that is not happening in design is how to exploit that exponentially growing analysis capability in a way different than just incorporating more analysis more often in the typical structure of design that we had in the past. And I think you're talking about more automation, and maybe you're going in that way, but how do you see this wealth of information being incorporated appropriately into the design without flooding your brain in a way that does not lead to any proper design conclusions.
A good segue to the educational part, perhaps, but the research clearly shows, the educational research, that creativity is locked in the right brain. And while the tools, as you say, give exponential capability, creativity is not developed by using these kinds of right or left brain activities. So to the educator, I think it's important to emphasize creativity is right brain activity. The only easy way to connect right brain and left brain is through sketching, drawing. You can do it on a tablet or whatever, but it doesn't work to do AutoCAD or computer drawing. And I think I'm trying to reemphasize this because we don't teach sketching or drawing anymore. We teach CAD. I think it's important to get your ideas to think about and unlock the right brain into the process.
But I think you also bring up another point, and that is that just because we can do a bunch of analysis doesn't mean we should.
Correct.
And so we have to be smart about what we're doing. You know, we kind of joke, since I've been involved with the CFD in particular, if you end up requiring CFD to run all the cases that you run in the wind tunnel, you're basically using the same power as required by the wind tunnel. And so you have to be careful about how you use the tools that you have. And I think there's a much smarter way of using them than historically we have.
If you give enough monkeys a typewriter, they will write Moby Dick, but a little creativity can shorten that process a great deal.
I don't want to go on too much, but what you said, Mark, reminded me many years back, a few of us were in a bar and looking at the Kansas City accident problem, and well, I wasn't actually there, but I'm told the story, and they basically, on bar napkins, came up with a concept for propulsion-controlled aircraft, and that napkin became the centerpiece of the entire design process and eventual flight test on a DC-10 of the propulsion-controlled aircraft concept. So
we talk about creativity, right, in the design process, and the issue is how to foster that creativity. Right. I mean, we may transition into education now, but I've always been intrigued in terms of organizational structures for design, particularly in this new world where we could have much more simulation capability, as to how to bring some of the basic ideas of brainstorming and that are used in the product design communities into the aerospace design. And these are areas that are very different from what we've done, yet their creativity in the process is much more ingrained than what we do. They're less encumbered by the designs we've done in the past and more driven by the requirements for this particular design, and I'd like to see a little bit more of that. Now, designing an airplane is very different than designing a potato peeler that's ergonomic or something like this, where the analysis is maybe not as central to the entire design process. So a marriage of some of this analysis capability with more open-minded brainstorming, right-left brain connection type capability is something that I'd definitely like to see in the future. Yeah.
I'm always amazed when I go to the library how many books there are on airplane design and how few books are on stapler design. Airplane design is an incredibly formulaic process compared to other design. I don't know that it needs to be so much now. I think that's what you're saying.
Yeah, I agree with
that. Okay, well, Mark, you touched on the subject, but let me sort of pause for a moment and sort of remind the audience that we really hope that you kind of engage in this conversation. We're going to go into our third subject and talk a little bit about the future of design education, but I'd really hope that you can begin to capture your questions, thoughts, comments, and begin to prepare, if you want to be vocal about it, moving towards some of the microphones that we have in the aisles. And that way, as we conclude this, we can have, again, the outreach portion of this dialogue. Okay, I'll start with a very simple overview of design education, in that we have undergraduate programs prepare undergraduate bachelor's degree engineers to go off into the world and at least have some experience in design. Some of the changes, even in the undergraduate level, I'm seeing are concentrations now in autonomy, autonomous systems, robotics, and that are part of this. So I see some fundamental changes in curriculum, certainly focus areas at the undergraduate level beginning there. And then we have graduate programs that begin to either be more discipline focused as we go off into research, but also some that are more systems focused as we go off and do advanced degrees. I mean, that's been the tried and true format for our design or engineering curriculum. I mean, what's the driver, if any, to change that? Are we doing it the best we can, as we've done for the last couple generations? What would make us change this?
I'm the old one, I'll start.
Go ahead.
The old one. Bob's not here. This sounds like the faculty meetings we have about changing the curriculum, and there are probably as many opinions out there as there are people. But I think one of the successes of aerospace education has been that we stress the fundamentals and allow people to adapt. In my career, we've gone from single stage to orbit, the space shuttle, commercial transport innovations, all down to micro scale Reynolds number flapping vehicles. And yet the engineers we've trained are able to adapt to whatever the design problem becomes, because we stress the fundamental rather than the hot topic of that particular time. So I don't think there's a big reason to change fundamentally what we do, but I think it's important to incorporate some of these things that have been found to help creativity, give hands-on experience like design, build, fly. I think that experiential experience is really good for our students to get involved in this process from an early stage, whether it's a simple model airplane or something really complicated. I think that's valuable.
So I completely agree on the fundamentals. I think those are essential. When it comes to integrating those fundamentals into design that includes all of those, I always have said in a joking way that the great universities in the US and abroad turn out excellent designers despite the curriculum that we teach in design. But, and I say that in a junky way because I think there are many good efforts around the world to try to teach the design aspects, not just the fundamentals. And for me, I've struggled with this over the years in the way in which we teach design. And I've come to the conclusion that the only way to learn design is by doing design, which reinforces the point that you're talking about. I see students learning about connections between the different fundamentals of the disciplines when you put them in a situation that forces them to think about those interconnections. So experiential, design activities, design, build, fly type things, even the ability to design, build, and fly a UAV in 10 weeks, which we do at Stanford in our curriculum, is the kind of experience that I like to see students seeing more of.
I have to return to the conversation we had in the bar earlier.
Not earlier, yesterday, right?
Oh, that's where I was in the bar.
Of all of our students that we're training, a very small number become designers. And yet this design experience seems valuable for all of the engineers that are looking for careers. I think they need to have that experience. It helps fit things together. But they're all not going to be designers.
So part of our customers, in the sense of the people we train, end up being folks that work maybe at your company and other companies, of course. So how do you see how the engineers have been trained for design activities in your setting? And how has that changed, or how does that need to change?
Well, I think, getting back to Mark's point, I think the fundamentals are extremely important, because you need to be able to tell when there's something that's not right. And sometimes when I'm asked, what are we looking for? There's been a lot of emphasis on being able to work with teams and having a very broad perspective of an airplane design. But I think there's a real need for having some detailed understanding of some of the basic areas of interest, whether it be active flow control, CFD is always an example, whether it's some of the structural details. You need to have people that are both, right? They don't have to be one person that has all that capability, but you need the people that have the advanced degrees that really can drill down into the detail of a particular subject. At the same time, you need those people that have the very broad perspective that can do the integration of a complicated system. And so it really is, As we said earlier, airplane design is not easy, and we need the ability to have both a wide perspective that may not be very deep, but also a very deep understanding of some of the basic technologies that go into it.
And I just have to, it's kind of an aside, but a comment, and having done this for a long time, when I first started, students would create these absolutely gorgeous airplanes. They look like something out of a Star Wars movie, beautiful. And aside from the comment that any airplane designer teacher out there will say, well, the landing gear's in the wrong place for the airplane to rotate, the common criticism would be, that's a beautiful airplane, but how can you build that? It has all these compound curves and you can't do that. And now, 30 years later, you could build that airplane quite easily, and the airplanes come out with tails that are perfectly square because they're using CAD, and that's easier to draw. What we design, completely products of our tools. And I think we need to try and divorce that if possible, that use the tool that you need to do what you're trying to do. Because they're there.
Yeah. Okay, so let me kind of add one thing here to kind of move this on, because you said something that struck me again, a memory from my past. These beautiful designs that come up and all that. I thought the world had changed fundamentally when I first saw the F-117. And we had moved to a new world where Maxwell's equations ruled over Reynolds and things like that, and just how are we prepared to design these new aircraft where the electrical engineers were in charge? Okay, nothing against electrical engineering, an important part of all this, but I mean, should aerospace design begin to incorporate all the other engineering disciplines at an undergraduate, graduate level, and because it really is a multidisciplinary thing,
Well, I think part of the education needs to be the ability to teach students that there needs to be always questioning what is the requirements and what's driving the design. It can't just be aero, it can't just be structure, it's all of those. And so giving them the tools, the talent to be able to look at that is, I think, extremely important during the educational process.
I like your example of the F-117 because, even though it may have been an ugly duckling from the aerodynamics point of view, I see it as an excellent design solution for the availability of the tools that were at hand at the time. On the other hand, it does point out one thing that I see in our design classes that is the thing that we don't do very well, which is the integration of the information that is available. And at that point, you just could not do that integration because you couldn't do a round surface that also had a low radar cross-section. But I think as we move forward, we are beginning to understand better how to couple the information that comes from the various disciplines and integrate it, not just in a computational way, but also in the heads of the students and the designers that eventually are going to make those decisions. So, yeah.
Any last comments, Mark?
There are questions.
Okay, let me try this one more time, get that chart off the page. And so we'll begin to wrap up the conclusion, but I really want to start seeing who we have here. There's one gentleman at the mic here. Could you please just, if you don't mind, tell us your name and then kind of address the question to us?
Yeah, thank you. I'm Chichi Wang from MIT. So when you talk about future of design education, I think it's important to think about how the role of a designer is going to change in 20, 30 years. Rich, it's interesting you mentioned the human computers in your introduction. So human computers were typical job in 100 years ago. So if they had a conference 100 years ago, they may have a session on the future of computing. And I don't know, maybe they'll imagine the job of a computer is going to disappear in some years. And instead of computers, we have computer scientists whose role is now completely different. Now when you talk about designers today, is it possible that the advance of computers is going to completely change the role of a designer in 20, 30 years? Instead of the left brain thinking, maybe the future designers have to have like more of a right brain thinking. Do you think that is going to happen? If so, how do you think the role of designer is going to change? And what has to happen for that?
I was taught in school that a computer is a high-speed mental moron. And I think with genetic algorithm stuff, it's much less of a moron than it used to be. And it does play a role in optimization. And yet, it's difficult to imagine it can create things that we didn't program or tell it that it should. So certainly computers play a much bigger role and will play a much bigger and bigger role. But I think the need for the creativity still exists. And when it's gone, oh my gosh, well then we're in computer museums where the computers come and look at us. So.
Juan?
Well, yeah, I agree with you. In the early phases of the conceptual design where you're creating that concept that maybe the computer is going to help you analyze, once you've zoomed in to a particular concept, I think Chi-Chi's question is quite relevant in the sense that the computer will allow you as a designer to have a much better idea of the design space and the variations within the design space. In addition, it may help you with things that the human brain cannot easily comprehend or decide. And the typical example I always give is designing a low-boom supersonic airplane. You and I know from classical aerodynamics and our foundational training how to make it high performance. But if something's wrong, it doesn't trim, and you have to move the aerodynamic center around, and you want to do it without affecting the boom, you and I cannot tell how you're going to do that. And the computer can actually be very helpful in elucidating what are the design changes that enable that type of success in an airplane design like that one. As the design gets more integrated, I think that's becoming more important.
So let me thank you for understanding my reference to female computers.
Yes.
I thought that would get lost on most of the audience, but I'm glad to hear someone caught it. We've got time for at least one more. We had one right up here in the front, and if it's quick, we'll move to one more back here in the middle.
I think it's a fantastic panel discussion on designing. One of the things that is missing from your discussion so far is selectivity of materials. I mean, designs can be beautiful, but the materials are the ones which will decide whether they will fly or not. Are you taking into account recyclability and sustainability of these materials when you are making all those beautiful designs?
We're getting a lot of
we had a lot of feedback on that.
It's pretty hard.
Was it a materials question?
It was a materials question. He was asking how you sustain the design with recyclable and sustainable materials and use that in the design. How is that part of your
composite
concept?
structures aren't the answer? Sorry, it's an old joke with some of my friends. Sustainable materials is there.
Sustainable materials and recyclability, right? You know, for example, most of these current materials, they're not recyclable, right?
Yeah.
So for example, the composites that you're talking about, you can't use them once they come out. So do you think of designs of the future which will take into account that we have to sustain the resources that we have?
Certainly should be a part of some of the green engineering research, green concepts that are coming up. I mean, this is part of the green notion. I certainly haven't been involved.
Well, and there is a lot of activity to look at how we can recycle or reuse some of the composite materials. And it may be for non-structural pieces when it gets recycled, but it's still an area that continues to be looked at on how do you reuse some of those materials.
Great subject. Let's make sure you submit it, and we'll focus on it next time. And because I apologize, everybody, we've hit past the 9 o'clock, but let's get that one more question in, please.
Hi, this is Greg Page from the Naval Research Lab. Good friends with several other people up there, so I'm going to you get a little bit of a curveball. I do most of my work in autonomous and unmanned systems, and our real requirements for future design aren't in the classical platform, aerodynamics, structures, even propulsion to some extent. Most of that's quite easily done these days. Our biggest requirements are really in the infrastructure side. And the unmanned systems, communications is definitely a short pole, as well as the ability to adapt to weather, dynamic mission planning, even reliability. We don't do the same mission like a commercial airplane does 37 times a day. Everything we do is a different mission, And the adaptability is a bigger factor than the outright performance. And I'd throw out to the commercial aircraft side of it, I think that there's a lot of that required there too that hasn't really yet been recognized. Specifically things like, if you see the more recent things, the last couple of days we've had some weather on the East Coast, and the ability of the system, as well as affected by the aircraft, the small number of aircraft in this case being possibly a factor, to adapt and to recover from that is probably kind of one of the new technologies that we need to start focusing on. And also people, and especially baggage handling, is definitely a short area there. On the way down here, it took almost as long to get our baggage back as it did to fly down.
Yeah. It's all a matter of how wide you make that control volume that you're doing the design around. But you're absolutely right. We could be looking at things at a broader perspective from when a person gets on their car to when they arrive at their destination. It should be much broader.
Okay, I want to thank the panel for giving us a very entertaining and insightful discussion on the future of design. I want to thank all of you for being here and allowing us to cut into coffee time and things like that. But don't stop thinking about this. Raise questions, express your interest. If you see one of us, or me in particular, since I'm looking at putting specific material into SciTech 2016 that continues this dialogue, moving from talking about what we think we know to what we think we should do, what are the actions that we ought to be doing as a community of interest in changing, looking, preparing for what we need to do 10 years and beyond from now. Okay, thank you all very much, and enjoy the rest of the conference.